So this notebook I am going to use a discussing about some SKlearn library, and also I will dealing with one project, and I am discussing a data set also in this classroom, and this is called iris data. Okay. Okay. So today in this classroom, we are discussing a data set which is name is iris data set. Okay. Iris prediction. Okay. So in the last class, so in my last class, you have done that how to create a logic regression model using a scratch of using Python. And that time I'm not going. I didn't use any predefined libraries, predefined model. I'm created that model and done that. So today we are going to use SKlearn, because SKlearn is like a very popular library in machine learning field. They are providing multiple functionality. If you're going with their website, official website, they are providing multiple things. They are providing classification model. They are providing regression model. They are providing clustering model. If you go with that any field like classification part, you see there multiple thing is available, multiple model like. This is a model name is K Never, Gaussian progress, cross computation, navy by decision tree, and so many things. Means you either you can be create that model by the scratch Python, or you can use directly their function, sklearn function, and you can be more focused on the project instead of focus on the their model. So this type of things can easily handle by the sklearn. So today I am going to use the iris data set. So let's understand what is the iris data set. So iris data, first let's understand what is iris. So iris is just a flower. If you go into the image section, if you go to the image section, so let's see this image. So guys, just one second. Okay, so here you see this is a image of a flower, and looks like a simple flower. There's some leaf are there, and everything is like displayed in the picture. So why we are discussing this flower in my machine learning things? So this is your first project. This is called the iris project. Here we are going to use this iris flower. Here I am going to use this iris flower as a data set, and we are going to create a model which predict the iris name. So let's understand why I am saying this prediction. If you see this second image here, second image, you see this all this flower looking similar, but their name is different. The first prefix is like iris, and second suffix name is different, like versicolor, setosa, and virginica. In this flower has three species actually. These three species are dependent on their leaf size. Dependent on their leaf size. Here you see, just one second, just using. Okay. Here you see. Let me. Here you see this is a leaf. The smaller leaf is called petal. The smaller leaf is called petal, and the bigger leaf is called sepal. Every flower has same things. This is the petal, and this is the sepal. This is the petal, and this is the some sepal. So every flower has some two types of leaf. One is petal, one is the sepal, and their size. This is a sepal width, and this is a sepal height. Okay, so this is a sepal width and sepal length, or sepal height, whatever you call, or petal length. So here you see this four type of input are provided. This is called the sepal length or petal length. This is your, okay, This is your petal width, this is your petal length. Same as this is your sepal width, this is your sepal length. So here you see this some type of information are provided, and their name is, this is the versicolor, this is the setosa, this is the virginica. So this is the data set. So let's first understand here what is the data set, what is the input field, and what is the output field. Okay, suppose we have a data set of this flower. So first of all we need this information: sepal length, sepal width, petal length, and petal width. So you can consider this field, this value as an input or feature, and their name is your label, their name is a label, their name is label. This is setosa, this is versicolor, and their virginica. So here you have an input of this and output of this. Okay, by using this input and output you have to create a model. When anyone come with new feature, like they are come with like sepal length and sepal width, petal length and petal width, you will be generate the output. Which type of output is this? Either it's versicolor, setosa, or virginica. The first question comes to my mind, that what type of model we are going to use. We are going to use classification model, or we are going to use regression model. Give me the answer of this question. Tell me which type of model we are going to use. We are going to use classification model or regression model. Hello, you can share your answer in the classification. Yes, definitely classification, because the output is fixed. Here output is fixed: setosa, versicolor, or virginica. Or input is like this. So here input is sepal length, petal length, sepal width, petal width, and so on. So now we need the data set. So you can be download. Suppose you are going to be like here, write iris data set. Suppose you are write this. So there is a website, archive, something like that. They are providing the data set. Okay, so I am going to open this data set, and this is the data set information. The number of rows are 150, or number of attribute, number of input is 4, and so on. If you want to download, so there is a download button. So okay, so suppose I am downloading this. So we I open, I guess it will not be open in my, just once again. Okay, just 1 second. Okay, just 1 second. Okay, suppose you download the data set, and if you want to see what the data is added, which type of data is here. So I am going to open this image. So see this image. This image has a containing a Excel sheet. Ignoring this ID, you see here what is that? Here multiple things here. There's sepal length, sepal width, petal length, and petal width. And in you have the output like setosa, or maybe the other will be also available, virginica. So here we see that this is the input and this is the output. So we are going to create a model. We are going to create a model. Just 1 second. So here I am going to create a model by using this input, all this input and output. By using this input and output, we are going to create a function. Okay, and that function, if you create this function, come with a new input. The new input containing what? New input containing sepal length, sepal width, petal length, and petal width. If you come with these two input, your output is either setosa and virginica and so on. So we are going to deal this data set like that. Okay, and also we are going to come with a training will be done with the SKlearn. I will show you how to create this training part by using this data set and so on. So now this is the data set, but don't worry, we don't need to download this data set for use purpose, because SKlearn already provide some data set for learning. Just one second, it should be data set. Okay, anyway, I will see this. So SKlearn already provide this data set. SKlearn already provides some data for learning. So we are going to, and also the iris data is also added here in the SKlearn. So now I am going to use and import something here which is helping me to start with the iris data set. Let's first I guess you have already understand what is the SKlearn, what is the iris data, and what's the iris data contain. If you have any issue to understand the iris data set, please let me know. Any issue for understanding the iris data set? Hello? Clear. So now, same as other library like NumPy and all, you have to import sklearn very easily. So you have to write sklearn, okay, and we are need the library dataset, and we are import a functionality is called load iris. This function contain all the information of the iris dataset. Same as suppose you want to import another dataset like load digit. So they are dataset providing the digit recognition, but I will deal with the later. So now I am going to use load iris. Okay, this is the code. So this is the code. This is the line of code for loading the. So I am going to write some info. Import iris data set SQL. Okay, now it's starting to compile and allocating the space. If any, though there is no spelling mistake, it will be run. Otherwise, it providing the error data. So now just copy this iris and write it here, and I am going to assign this a variable iris, and this is the calling this function iris or calling this object. So now it's run. So this iris is a like a similar. This iris has an object containing some information. So what the information is containing? So first, if you want to see like just one second, print iris. I don't know what is the printing this. Okay, they are printing entire thing like data and other information. So I will dealing with one by one what the information is contained. Suppose we are going to write data. So iris data contain the information of the data or maybe the input feature. So if you run this, you see there's something is number is printed here. I know you are difficult to understand what the number is that, but I will discuss in few minutes. So okay, this. And this number is returning a numpy array, and this number containing this. So here you see this returning a 2D array. First array containing another array and another array containing 4 element. Okay, 4 element. And I guess you can understand this 4 element is nothing. This is the information of the width or length of the sepal and petal. So you can consider this is a sepal length, this is a sepal width, this is a petal length and petal width. So this is the things we are going to discuss. Now, if you like just iris dot target. If you're writing the target, so in my first class I already explained sometimes output can be described by the label or the target. Here you see 0, 1 and 2. Okay, but if you see this image showing this iris, this output is returning as a Iris setosa, Iris versicolor, and Iris virginica. But in your case, the output is like 0, 1 and 2. Basically this is nothing. You can be like understand 0 is nothing. 0 is like versicolor, 1 is like setosa, and 2 is like the virginica. If you want to confirm a same as for this data set number, how can understand this is a sepal length, maybe this is a petal length. So this data set also give the detail for understanding the data set. So you can write iris dot feature names. So if you write this is returning a array containing the information. It is a meaning that first data, this data is nothing, it is your sepal length. Second element is called sepal width. Third element is the petal width. Fourth element is the petal width. And same as if you want to understand what is the meaning of 0, what is the meaning of 1, what is the meaning of 2, you have to write iris target, sorry, name. And in this case, you have seen what is the meaning. Target. Just one second. Setosa, versicolor, and versinica. It means 0 is indicating for the setosa, 1 is indication of versicolor, and 2 is indication of virginica. Guys, this is clear? Till this point, any confusion at all? Akanksha, Selja, Himanshu, Mohan. Any confusion? Good. Now, so your input output is ready. Now we are going to create. Okay. Now we are going to create a model, but I am going to write some processing to understand this. So I am assigning X with iris data and Y iris target. Clear? X, Y is ready. Now run it. Now next. Okay, now next. So guys, here you see this data is ready, but now we have to split the data in two parts. Like what? Like training data and testing data. But question is why we split the data set? So let me explain it my workup, because this is something you have to understand, and we have to connect my, where is my wire? Okay, anyway, my wire is now there. Okay, now. So basically, what is happening, guys? Why we need to train to split the data set and checking the accuracy in the same data set? Suppose this is your graph and this is your input field. Okay. Now we are going to create a model. First model is a model which is going like that. Okay. Second model is a model which is looks like that. So here is called, oh sorry, it's called M1 or it is M2. Now tell me which model is best, M1, M1 or M2. Now tell me which model is best. There are two model. One model is a model who have some large number of error, but if you follow this function, they have less number of error. This M1 is a model who was try to passing through all the point but not able to pass. But M2 model is like high level of equation model and it's passing through all the point. So tell me which model is best, M1 or M2? Selja told me that M1 model is the black line is best. And other people, please tell me. And also we have to tell why the M1 is best and why M2 is best. Hello. Only Selja are giving the answer, not other people. Please tell me. Whatever your answer, please tell me. You are going with M1 or you are going with M2? Akanksha, Himanshu, what's your thought? Akanksha saying M1. Himanshu, what's your answer? Mohan, Ayush, Mathli. Okay, let me explain. Some people told that M1 is best, some people told M2 is best. But let me understand this. You have trained the model and you have find the model. Means if you are going to check the accuracy, if you are going to check the accuracy, this M1 is best and M2 is best. I'm going to consider. Suppose this is your, let's consider the M1 model and M2 model. You have trained the model. If you seeing this, every time you are going like less number of like this is the, this time the accuracy is good, not good. Accuracy is bad in this case, and in this point the accuracy is like good for M2. But now I am going to import some more point. Okay, and this point is like okay, let me explain, let me remove this and draw some different graph, because we are learning classification, so we are dealing with that. Okay, now so I'm going to put 2 point, 1 point is blue. Okay, then maybe you will understand what is happening. Okay, okay, let me add some red color. Okay. So now I'm drawing the model one. So model one is like a model, something like that. It is a classifier model. This type is considered blue. This type, all the point is considered as a red. Now consider to another model. So this model is like is something is like that. Okay, means from that area it is blue and that area is red. So now there is two models. This is the M1, now M2. Now tell me, I guess this time you are clear. Man, this is a classifier model. First classifier is M1, second classifier model is M2. This classifier model tell that this area is considered as a blue part area, this area is considered as a red part area. But if you're going with the M2, you are seeing this part is area, as all the part is area considered as a red part area, blue part area, and this part is the area is considered a red part area. Now tell me this time which model is best. Everyone, please tell me. If you're not understanding the question, please let me know. I will repeat it again. Your question is, this is a data set, and data set you are going to train a model, and after the training you are finding the two model. One model is M1, one model is M2. M2 means this is a classifier, this is a classifier, and you are saying that if you going with this model, every point, every new point, this area is supposed to be a red blue area, this area is supposed to be a red area. If you are going with like mean this is a classifier model, and you are classify this data like this way. This if you're going with this model, this m2 is almost for every point m2 is right. But if you're going with m1, some of the point they are giving the wrong answer. If you're considering this point, blue point, if you're going with this point, like this point, if you're considering this point for m1 is supposed to be blue, but this is a red. Reality this is a red. So this m2, this m1 is giving the wrong answer for this point. Also this is giving the wrong answer for this point. Also give this giving the wrong answer for this point. Also this giving the wrong answer for this point. But if you're going to the m2 tell that this part area is blue, this part area is red. If you're telling this point is red and this is also a red, this point should be a red, this is also a red, this point should be blue and this is also a blue. So M2 giving the almost the right answer, but M1 giving the 96 or 95% giving the right answer. So which model you should be say this is the best, M1 or M2? Other people, Himanshu, Akanksha, Selja, Selja, Mohan. Okay, now most of the people they'll tell that M1 is M2 is best over M1. But giving guys, I'm giving you idea that M1 is better than M2. Why? Let's understand. This is called the overfitting. This is called the overfitting. And in machine learning, when you train the model, you have to avoid the overfitting. Means overfitting means during the training, if you're training giving the right answer every time, then you have to be understand this is part of the overfitting. So it is meaning that M2 giving the right answer most of the time, means that is the part of the overfitting. But M1 giving the answer 90%, 92%, 93%, this model is giving the right answer. But M2 is giving the 99.99% giving the right answer. So means M2 is follow up the some overfitting, but M1 is not giving the overfitting. So why overfitting is bad? Why overfitting is bad? So answer is M1 is better than M2. Answer is this. Why? Because of overfitting. Why? Because you overfitting. And why overfitting is bad? Let me give you the answer. So suppose during the training you have a 70% data set for training, and after the training you have done this model. Now you have rest point is 30%. Okay, 30%. Now I am going to put my 30% point. Okay, so choose my blue color. So I am giving you blue color. Now 30%. This is 70% point. So now I am giving the point 30%. So this is a blue color. This is a blue color. Okay, and now some red color. Okay, now guys, after training you will create two model, M1 and M2. In 30% data set you have created two model, M1 and M2. If you are going for this data set, you are giving the right answer for most of the time in M2. But after importing the next data for checking the accuracy that your model giving the right answer or not, and you see that most of the cases your M2 model giving the wrong answer for the rest data, but M1 giving the most of the time giving the right answer for the new data. So you have not only consider the training data, but you have to also consider the testing data, because testing data is not used during the training, not used during the training. So I will give you the real example what is happening. I will try to relate. Suppose you are going to suppose you are going to give suppose you are going to in exam, and you know your means 10th exam, suppose 10th or 12th exam, and you are practice with the NCRT, and suppose most of the question comes from the NCRT, it is very high chances you are going to score very well. But suppose the question comes from different books, so maybe you are going to be decrease your number in your examination. But there is one more other student who are practicing every book, and they are not dependent on the question, because if you NCRT means there is short the question, and the number of question is fixed in the NCRT, but in the if you using another books, so maybe you are very high chances that you will crack very you will score very well if you comparing with the NCRT guy. So means your model is not only good for the your data set, your training data set, but also this model is good for the generalized data set. Okay, when every data your model should be written the good answer, not only the training data. So you should be understand. You should be also avoid the overfitting. Means that two things. You have to check the data. You have to check the your model with not only for the training data, but also check the model for the testing data. And you should avoid the overfitting. Clear? I know that it is difficult to understand when the overfittings come, but during the practice and during the I will explain these things in later class also. That's why overfitting is bad. And in a deep learning I also introduced how to avoid the overfitting and what is the solution to avoid the overfitting. Clear guys? Are you understand what I'm telling right now? Why M1 is better than M2? Means your model should be generalized, not good for a particular data set. So if you go to M1, M1 is good for generalized data set. Yes, this is giving the right answer for the 90% only. But this is the right giving the most of the time, this is giving the right answer 90%. But M2 is only good for particular data set, not for the every data set. Clear? Clear everyone? Everyone clear? Akanksha, Shelja, Ayush. If you are not clear, I will repeat it again. That's why before the training we'll generally split the data set. So we have to import one more library. So from sklearn dot model selection, I guess this is the spelling is right. Import train test split. Let me run this. If this is running working well, okay now. So now we have to call train test split and pass x and y. Okay, and they are returning four variable: x train, x test, y train, y test. Okay, and so we can add test size 0.25, means 25% is going to be testing data set and 20% is going for the training data set. Let me run it. Now I am going to check the same. So print. Okay, first let's see how many rows in the data set. So let me add this. Print x dot shape. So you see there is a 150 rows, means the 150 data is available and 4 column. And now you see save, and also we have to print save. See 112 rows is go for the training and 38 rows for the testing. Generally you have to get put more data for the training and less data for the testing generally. So this is ready, your data set is ready. This is the data set. Now we are going to start the model. In my last class I used the SKlearn, the last class I used the logistic regression. So in this class I am going to use the same model, but this time I am not going to write the code in the scratch, but I am going to use directly import this SKlearn in my class. So I am going to use SKlearn from SKlearn, and you see just one second, let me explain. Just one second. SKlearn logistic regression. If you go to this, and if you want to see this document, you can see the documentation in the letter, and this is the code. Sorry, where is my code? So you see how easy you have to import the logistic regression. Same as my model, logistic regression has multiple functions. If you like, just go to evoke this documentation, and I'm going to see. Just one second. Okay. Just one second. I guess this documentation should be explained. Okay, there's some method which is important. Method is this. This is fifth method, same as in my last class, and that predict method. I'm going to use this method to solve the most of the problem. Okay, and okay. So we need to start the training because this logistic regression is not trained yet. You have to train your data set. So now just create, just create a variable log race, and you have to call this logistic regression, which is the SKlearn object, and we have to add like that. Okay, and now we have to start the training. So before the training, in my last class, you've seen multiple terms we are using, like the learning rate, like the number of epoch. By default, this all this value is set. By default, is all the values set. So let me print this variable. What the variable is this? Let me see what the variable is this. Sorry, just one second. Okay, just one second. Hello, now is it clear? Hello, hello, hello. Not clear, everyone? Yes or no? Still, yeah, clear. Now, logistic regression is ready. You see, I should be see this printing directly. Maybe this will be written. Yeah, this will be written the some explanation. Uh, I guess they are not explanation. Okay, I will see this everything in my just one second. So you see this logistic regression is ready. So let me train first. I will explain what is the epoch, how to set the learning rate and everything, but let's understand how to go with the default value. So logistic regression, log race, and we have to use fit method. Fit method need the data set. So data set is xy, but we already split the data set in two parts, so we should be go with that field. So instead of writing xy, I need to be use xtrain and xtest. So this is the things, and now we have to start the training. So why this issue is here? Oh sorry, not white waste. Also this is not working. White train. And now it is start the training, and after the certain number of training, you see the logistic regression is ready to use. And now logistic regression is ready to use. Model has been trained, and we are going to predict. So this is a prediction, and prediction need the input. So I am going to use an input field. So I am just copying this part. Okay, only changing some value. Suppose I am going to use 4.1, and I am going to 2.5 or 1.24. Suppose this type of random number I am going to pass here, and now I am going to predict this. Here you see 0 is the output. So 0 is your output. So I am going to be like prediction. So it is meaning that predictions. Okay. So if you go to the prediction, you see this is returning an array of 0 number, but there is only one input is passing, so you can be considered 0. Okay, so 0 is the output. So you know 0 is the thing. 0 is coming from iris dot target names, and this is an array. So I'm passing this array value here, and you see just one second. Setosa is your output. Means if you go with this input, this is your output. This is your output. So guys, you see this logistic regression is working. So now I'm seeing the accuracy, how the model is working. So you know guys, the model accuracy will check very easily by going with the So I'm going to write predictions, y prediction, and I'm going to use log race and predict. This time I'm going to predict all the test data, all the test data. So after the split is in, we have the test data also. So I am going to predict the test data and passing this text data here. So this is your prediction. If you see, this is your output. Okay, 2, 1, 2 and so on. So now I need to find, this is same. So there, this is the real output. This is your real output and this is your prediction output. So if you comparing this like 2, 1, 2, 2, 0, 2, so maybe some point they are giving the wrong answer. Okay, then only the few numbers. So I will try to be comparing this. Okay, see, here the 1 is output, here the 2 it is output, and some of the point is giving the right answer. So guys, I am going to see this. I am not going to comparing like that. I am going to use SKlearn another function, and this is called matrix, I guess. Matrix import accuracy score. Matrix accuracy score. Let me check this. SKlearn matrix. So if you want to see their documentation, so this is the code. So maybe I some spell mistake or something like that. That's why giving the wrong compilation. So I'm going to copy and paste and fix it. And now I'm going to check accuracy, and accuracy need two things: your real output or prediction output and your real output. So this is your okay, and if you see, 97% time this is giving the right answer. 97% time this is the right answer, and you can see this model is good if you going that. So now I'm changing their test size. %40 data I'm going to giving the for testing. Now see this time what is happening. See, I'm training again everything. And see, the accuracy has been increases. So maybe your accuracy will is giving the different tab. So you have to also choose wisely the splitation. So generally don't use large splitation. Most of the time 30% or 25% data is enough for the training. So I will recommend you to use this type of splitation. But don't worry, this data is so too small, only 150 rows is there. Maybe in the upcoming classes the 1000 row and the 2000 row will be available, and that time you have to choose various things wisely to which type of displacement is okay for the data set. So now this type of thing is completed. The training is done. Now you see the logistic regression is there, but what about the epoch? What is happening with the epoch? So if you see this SKlearn logistic regression, to go with the argument, okay, you see this argument here, the maximum number of addition taken to solve the conversion. So this is nothing guys, this is your epoch number. By default it's set to be 100 and your model is too small, the 100 epochs is okay. So I am going with that max ITR and passing this argument here, and I'm passing I am only 5 epochs. So see what is happening with the 5 epochs. And your accuracy decreases by 93%. So everything is same, only epoch you have changed and it is decreasing by 93%. Suppose I am going with the 2 epochs or only 2 epochs. Who is coming here? And see, now only for 2 epochs is giving the wrong answer, starting giving the wrong answer. Anyone who is here to join? I don't know. And see, accuracy has been decreased to 28%. Hey Goswami, the class timing has been 7 now. You are joining link late. So try to join the class on the time in the next day. And I will repeat the class once in my upcoming day. But join the class on time 7. Hello. Salam. Class okay. So see, your accuracy has been decreases. So here you can control your logistics model. Means it is not like only you just import and use. You also focus on their argument. Okay, which ITR is okay. Why I'm using 100 ITR, 100 epochs. Why I'm using the 50 epochs. Why not 1000 epochs? You can also go with the 1000 and 10,000 epochs. You got to do that. So not only just importing and use that, you also focus on this argument things in my for training the model. If you like another argument, if you see these other things like the learning grade is also available here. Let me check the learning grade. But don't worry, learning grade is always good by default. So we are not change that things in my classes, but go with that. So here you see this guys, see how the logistics work for different epoch and giving the wrong answer and right answer for different epoch. So in the next class, I am going to use things it's called model evaluation. Means here you see that you have to see the accuracy, but also see which model is best. Means model evaluation. This is the next topic we are going to discuss in next. Means what the model evaluation. Suppose the logistic regression I am going to use here. The logistic regression, and I am going to pass Max ITR 100. Same as I'm going to pass like 50 or 60. Same I'm going to pass 90. So you also consider that which epoch is best. This epoch is best, this epoch is best, this epoch is best, this epoch is best. So this is called the model evaluation. So second day I am going to consider different type of things to understanding the model evaluation. Which model is best. You are not only focus on the training but also focus on the attributes, also focus on the argument. So next class I am going to discussing this part and we will understand how and why model evaluation is important. So if there is any issue to understand this this iris data set and this prediction and SKlearn, please let me know. If you are facing any things, any issue, please let me know. Just okay. Okay, guys. If you are facing any issue, please let me know. I will here to help you. And if you have any query related to machine learning and like understanding Colab and code, you can share with me. I can help you. Any question, any query. Himanshu, Akanksha, and other people. No question, no query. All set. If you don't have any more query, otherwise I will log off and complete this class. Okay, guys. I have guess you have done, and let me share the sheet, the collab part.